Today I received a Sony Beta. This is, I think it's an SL330 that was bought off eBay. That's your first clue that it probably doesn't work. But the guy has a bunch of tapes. He didn't want to pay me to transfer them over. He wanted to do it himself. Well, guess what? He's now going to pay me to fix his machine. And this one here is actually quite complex. Let's check it out. So this is Sony Betamax. This one's a Super Beta model. It's a, what is this one? An SL330. This one was brought into me by a client who bought this unit for $100, was assured that it was working, but it doesn't work. And he's got a bunch of beta tapes that he needs to copy. Let's take a look at what this thing's doing. So I'll press the play button. And that's all we get. We get no sound. The counter is moving at the correct speed. If I show you the tape counter, is moving at the correct speed. Therefore we know the tape is moving because this reads the control track. But we have no picture. And more importantly, if we listen to when it started up, I don't hear the drum starting up. So let me get the screws out of this thing, and we'll get the top off this one, and we'll take a look and see what this one's doing inside. As you can see, I put my Sony training video in here. Okay, the drum is spinning, but that's nowhere near fast enough. So we have a servo problem, it looks like. Servo on this is over here. Servo circuit's over here. Could be a bad capacitor. Could be a bad No, the FG, if it went bad, it probably wouldn't turn at all. I'm thinking we may have a bad, either a transistor that's gone bad. Probably not. More than likely a capacitor. This is our driver IC here. Looks like. I don't know which one's which. Control amp over here. This is probably the capstan servo on this one. And I don't know where the drum servo. FG amp. We'll try the wet finger. Just lick my finger in. Okay, I can hear all the safety people screaming right now. No, don't do this on high voltage stuff. This is 12 volts. It's pretty safe when you're dealing with low voltage. You're not going to get a shock. But yeah, if it was line operated, keep your fingers out of it. If I had a schematic, I could go right to the circuit. But unfortunately, I don't have a schematic, so I don't know the area where I got to go on this. So I'm just kind of trying to see if anything will change. So I'm not going to talk while I'm doing this because I want to listen for any changes of motor speeds. Seems to slow down when I touch right in this area. Notice that the drum's slowing right down. So we may have a problem in this area here. There's a couple capacitors in here. I wonder if we can measure any signals. Let me get my scope out. Do some probing around on here. Let's see if there's any signals that I can read in the servo circuit. The capstan motor is going way too slow. But why is the question. So I'll get my scope out. I don't see any signals anywhere here at all on any of these pins. Okay, DC, DC, there's DC there, there's nothing there, nothing there. Okay, there's a pulse on this one. There's a pulse on that one, and it does not change when I change my scope over to AC coupling as opposed to DC. I'll show you guys in a sec here when I finish measuring this. I'll show you what waveform I'm getting. Okay, that appears to be a PG pulse there. What else is here? Nothing there. That appears to be a feedback from the motor. Take a look. I'll show you guys the scope. Yeah, I know I'm using my analog scope today, but I'm working on an analog machine. If I scope that, what was it, a transistor? Is that what I'm looking at here? What am I on here? That's a transistor, although it's not really, it's not well labeled. Anyway, there's a capacitor, C927 is on here as well. But when I scope this, okay, I'm seeing a pulse. If I bring up my gain, see, there's the pulse there. And if I slow down the drum, that pulse changes. Slow down the drum, right? So that is definitely, that's definitely related to the speed of the head drum. And that transistor, I think it's a transistor, it's not marked here. I have to look on the bottom, but I don't have the bottom off the unit yet, but that goes into C927, which has still got that pulse on it. But then that goes back to the IC. That one doesn't change when I slow the drum down, but this one does. Okay, here's something else interesting. This is pin 14 of IC904. You see it's just doing this up and down, up and down. If I slow the drum, that changes. I think there's something in this area here. Where I was probing was, I was probing here. Where's my probe? So I was probing here and here. I had the square wave on this one, and this is the one that was going up and down when I was slowing the drum. Like it was slowly going up and down like a DC shift. That was the one that was doing that. I'm curious as to whether this capacitor here, where are we here? Where am I? This one here, C927, might be a bad one. I'm just going to pull this cap and we'll measure it. So let me just get the bottom off this unit. We'll pull this one out and maybe even just replace it for the hell of it. Okay, here's a look in the bottom. This is the capacitor here that I was measuring, and that transistor that I was seeing the pulse on was this one right here, Q907. So I'm going to just change out this capacitor here, just for the hell of it, and we'll see whether that makes any difference. I kind of think it might, because I think this might be the sample and hold for the servo. One of these is going to be the sample and hold. I think this one might be the one. I'd have to look at the schematic, but it's one of these guys in here. It's going to be the sample and hold. So basically, what happens is, as it's sampling the FG signal and comparing it to the incoming sync, or sync coming off the tape from the control track or from internally generated sync. When it samples the FG frequency generator on the drum motor, then what it does is it generates a voltage that, if the drum is going too fast, the voltage will drop, and if the drum is going too slow, the voltage will rise. So once you get to a happy medium, that's where it will hold the drum at a constant speed. And what can happen is, if the cap starts to go electrically leaky, it won't charge up to the right voltage, and then you'll end up with a drum that's running too slow or too fast, depending on what way, whether the voltage is higher to slow it down or whether the voltage is lower to slow it down. But anyway, I think we'll take that cap out right now, and I'll put on the ESR meter just for the hell of it, but I think I'll be ending up just changing that one, and we'll see what happens. So I'm just waiting for my soldering iron to warm up to temperature. It should be hot enough by now. We'll just remove that capacitor. Can't see what I'm doing. Light's on the wrong side of the board here. Okay. What's this one? This one here, C927. Now remember, this is the bipolar capacitor. I don't have a bipolar. We can make a non-polarized or a bipolar cap by taking two regular polarized capacitors and connecting the negatives together. So I'm going to connect the negatives together, solder them together, and then we'll install this one and see whether that will solve our problem. Okay, new caps in place, or two caps to replace the one. We're just going to fire this thing up now and see whether we've made any progress. Well, it's got our drum speed back. Oh, we have a picture. Well, we don't have a very good picture.
In the record circuitry, where we do this emphasis, obviously when we play it back, we're going to have a look at what...
Don't worry about the white lines. The white lines you see there are just caused by the plasma being picked up from the head. If I bring my hand near the head, it'll get worse, you see. That's just interference from the plasma, but we have horizontal instability now. Big time horizontal instability. But we've solved one problem. And that problem is... Oh, interesting. So I'm just touching. I'm just touching the set, doing the wet finger trick again. I've solved more problems by just licking the finger and touching some of the signal circuits.
This is one of their attempts to get better at high frequency response, jacking up the RF signal.
Sometimes our friend is a wet finger. To kind of isolate things. Interesting, this other capacitor right here. this other capacitor here. This one here, when I touch this one,
Together, they add up,
the picture clears up. I'm just gonna change this one
and
while I'm at it. I'm not even gonna measure it. I'm just gonna change this other one here. We'll change that one as well, and fingers crossed that's gonna fix the problem. We're definitely in the right area, and changing this one cap got the motor speed back, but it's still got some instability problems. So let's just do this other one while we're at it. I think it's this one. Yeah, it's that one. C929. Another, oh, this is a 2.2. This is another bipolar. This one's a 2.2. So we'll have to do the same thing again. I'll have to get another couple capacitors and we'll put them in series, and with the negatives connected, we'll put those in series, and we'll try that one. Stand by. Okay, that's got the cap replaced, cleared off. Let's see whether this one has been resolved. Power on. Are we going to get a picture?
in the North American.
Yes, we are.
But in Japan, they call
Okay.
it high band.
We're still getting lots of interference. Let me put the bottom and top cover on this thing to try to shield it a bit. Or I can plug it into my CRT monitor. Well, let me get the top. We'll put the top cover on and shield this thing a bit. That's just interference from the plasma, guaranteed. I've got the bottom cover on now. We'll see whether the picture's any better.
These are not
Ah.
scale. Just to give
What do you know?
an idea that
Yeah, this is my Super Beta course. When I was working for Sony, and actually this was not when I was working for Sony. This was after I left Sony, and I was at the Sony service department. They came out with Super Beta, so they sent us on a seminar. So I took a camera and filmed it. This whole course is up on my YouTube channel, by the way. If you guys want to see this really dry, obsolete technology, this old obsolete theory. That edit was done, by the way, an insert edit by an SLHF 900. That's what I was using back in the day. This is still interference being caused by the plasma. You see as I move my hand near there. If I take the top cover and put the top cover on, that should go away. I guess I have to put the screws in to shield it, but that's interference from plasma. That noise. Anyway, let me try another tape on this one. I have a Beta 1 tape that I recorded, and it's not in Super Beta, it's in just regular Beta 1. I probably shouldn't be showing this. This is stuff that I downloaded off of YouTube, and it's been where is it here? Tracking Time Storm films and stuff. There we go. So I can't really show this. This is just all stuff that I got this off of YouTube. Just demos and stuff, right, that I put onto a Beta 1. Put my hand in front of there just to try and block any copyright, because I'm doing that because I've been hit by copyrights by showing clips from stuff that was taken off YouTube. Anyway, there it is, Beta 1. It's you can see how quick that tape is moving. It's moving along at a pretty good rate. And this is not in Super Beta. This is in Beta 1 regular speed. I actually recorded this on my old SL SLO 340, I think. That's what I recorded this on when I had that going. And then no sooner got this tape recorded, and that deck decided it wasn't going to work anymore. So maybe that'll be a future video to work on for another beta. But this one here is done. This one here is a paying customer. So this guy's going to pay through the nose to get his Betamax fixed. I figure he's already got $100 plus shipping. Bought it off eBay. So I figure he's already put $100 into the thing. He can put at least another $100 into making it work. What do you guys think? At least $100 to fix that, because nobody really knows much about these things anymore. Shops have all shut down, and his options would have been to send it back and pay the shipping, and that's what he was telling me when he brought it over. It's going to cost him almost $100 to ship the thing back. He told me how much it cost him to get it here. It cost him $140 in shipping to have this thing sent up from the States. Plus he paid $100 US for it. So he's got $240 into this machine now. And to send it back is going to cost him another $100 to get back his original $100. So I figure if I can fix it for what it would have cost him to ship the thing back, and he won't get back his shipping, right? So even if he ships it back and gets his $100 back, he's still $240 into this thing, and he has nothing. So I figure if I can come in at less than that, I'm going to be a hero. So I'm going to be a hero. Anyway, thanks for watching. As I say, this gets this thing back running. Guy that owns this thing tells me he's got almost 200 beta tapes of his kids when they were growing up in the early 80s. So he wants to transfer them all over to DVD, and because he's got so many tapes, what it would cost him to ship the tapes out would be cost prohibitive. So he wants to transfer all of his tapes over, and now he has a machine to do it. So regardless what he pays to have this thing fixed, it's still cheaper than paying someone $15 or $20 or $30 per tape to transfer them over to digital. There you go. Anyway, that's this one. Thanks for watching. We'll catch you again in the next one real soon. Bye.